Hello everyone, my name is Diksha and I am from the Bodhi Academy. Today I am going to continue with the Goa Board Chemistry paper, that is of 2024-25, and we will finish the paper solving today. So last time, in last part, we have seen question 28. Okay, till question 28 we have solved the problems. Now we will do from 29th question. So 29th question is, draw a neat label diagram of refining method used to obtain semiconductors and other metals of very high purity. Here they have not asked directly which method they are talking about. So they have indirectly asked the diagram of refining method used to obtain the semiconductor and other metals of very high purity. So this method is called as zone refining method. Okay, the name of the method is zone refining method, and that is used to obtain the semiconductors and metals of very high purity. So this diagram you will get in the textbook. So you have to draw a neat diagram of zone refining method. Then under that, one more question we have is, write the principle of hydraulic washing. Now the principle of hydraulic washing, it is based on the differences in gravities of this gangue particles and the ore particles, meaning based on their gravities, okay, ore and gangue particles, they will get separate out. So the principle behind this is, it is based on the differences in their specific gravities of ore and gangue particles. The next question is, select the ore amongst the following in which calcination is carried out. So in our principles and methods of isolation extraction chapter, that is metallurgy chapter, we have this process. So in calcination, okay, so in which of this calcination is carried out? So zinc blend, no. Iron pyrites also, it's not. But calamine, in calamine calcination process is carried out. Okay, so after reading the chapter you will get an idea. Calamine is the answer. Next chapter is from organic alcohols chapter. Next question, that is, write the IUPAC name of the given compound. Okay, so this compound is given. So you have to name this according to rules. According to rules, since OH group is attached to this carbon, numbering will start from this. So 1, 2, 3. Okay, 3. So prop chain we have. Now here we have double bond at second carbon. So the name will start this way. Prop, 2, in, and all. This is all, no, alcohol. So it is present at first carbon. So 1, all, or direct you can write all. So prop 2 in, 1 all is the answer. Next question, out of phenol and ethanol, which one is more acidic? So here phenol is more acidic. Okay, they have not asked the reason, but if they ask, then you can say that since phenol, in phenol compound, or in phenol there is OH group which is present. Okay, so hydrogen which is present in that, it is in conjugation with the double bonds which are present in the benzene, meaning that ring. Okay, so that's why it is more acidic than normal alcohol. Okay. Next is, write the preparation of tertiary butyl methyl ether by Williamson synthesis. So we will write the reaction over here. Tertiary butyl methyl ether. So first we will draw the structure of tertiary butyl methyl ether. Ether means this type of structure, that is ROR. Okay, ROR. So tertiary butyl. So at one side we have tertiary butyl, other side we have just methyl. So we will write this methyl, then in between O, and then this is tertiary. Okay, so this is tertiary. So this is our final product, but how to prepare this, that we have to see. So write the preparation by Williamson. Now Williamson synthesis, how we carry out Williamson synthesis? So we take sodium salt, or we take sodium whatever alkyl group we want, we take the sodium salt of that alkyl group. Okay, so here we got tertiary butyl, no? So that's why we have to take this group, CH3C, CH3, CH3ONA plus CH3Br. Okay, so this will give us this product, meaning then what happens, this sodium and bromine, they combine to give sodium bromide, that is NaBr. That is a side product, and here we get our product, that is tertiary butyl methyl ether. This is how we have to prepare by using Williamson synthesis. The next question is from solutions chapter. Draw a neat label diagram or graph to represent the elevation and boiling point of a solution on addition of non-volatile solute to a volatile solvent. So here basically they have asked the graph for elevation in boiling point. So you have to draw a graph this way. So it is basically vapor pressure versus temperature. Okay, so here see, here elevation boiling point means what? Whenever you have solvent, no, then the boiling point of solvent is always less than the boiling point of solution. So when you add something, any solute in that solvent, then it becomes solution, and that solution we will have higher boiling point. So that's why there is elevation in the boiling point, that's why it is given this way. And difference between the boiling point of solvent and solution, solvent and the solution is given as delta TB. So delta TB is equal to TB minus TB naught. Okay, this is TB minus TB naught. So this is a graph. And next question here is the problem which they have asked. Calculate the molar mass of substance when 12.5 gram of solute is added to 250 gram of water, which elevates the boiling point to 0.50 Kelvin. Now we have to calculate your molar mass. So molar mass we represent it as M2, molar mass of solute. Okay, we have to calculate. Then what is given here? Given mass of solute, that is 12.5 grams. So I can write here it as W2. So it is 12.5 gram. Then 250 gram of water. Water is a solvent, so we can denote it as W1. So it is 250 grams. Then next is they have given the difference in their boiling point, that is delta TB, which is 0.50 Kelvin. So delta TB is equal to 0.50 Kelvin, and Kb value is also given. Kb value is 0.50 Kelvin kg per mole. 0.50 Kelvin kg per mole. Okay, now we have to find M2. Okay, so we will write the formula of M2 here. Okay, the general formula here, delta TB is equal to Kb into W2 into 1000 upon M2 into W1. But we have to find M2 here because delta TB is given. So we will write M2 is equal to Kb into W2 into 1000 divided by delta TB into W1. Kb value how much is given? Kb value is 0.52. So here I will make changes. 0.52. So I will write 0.52 in place of kb. W2 means given mass of solute. So W2 how much is given? 12.5. 12.5 into 1000 divide by delta TB into W1. So delta TB value is 0.50 and W1 is 250. 0.50 to 250. 250 and 1000 we can directly cancel and we will get 4 as an answer. Then okay, so after doing calculation we are getting the answer. This is 0.52 and 12.5 into 4. So here we get 50 as the answer and here 0.50. 0.50 and 50 we can cancel and here we will get 100. So it will be, to shift this 2 points, so it will be 52. So M2, that is molar mass of solute, is 52 grams. So this is our final answer. Okay, then next question is draw a neat label diagram of reverse osmosis. So you have to draw a diagram of reverse osmosis, okay, which is from solution chapter only. Reverse osmosis means what? We are doing exactly opposite as in the case of osmosis. So here this is a rough diagram that I will draw here, which is properly given in your textbook, okay. So this kind of diagram you have to draw. You can refer your textbook for proper diagram. Okay, so here what happens? Pressure. We are applying external pressure which is more than the normal pressure of the medium. So when you apply the external pressure which is more than that pressure, then it will start going opposite, meaning it will reverse. Osmosis will be reverse. So that's why it is called as a reverse osmosis. Then next is again problem. Calculate the osmotic pressure of solution containing 68.4 gram of sucrose. So we will write the data again. So 68.4 is W2, which is given mass, so 68.4 gram. Then W1 is the given mass of solvent, which is given as 1 liter, 1 kg, so it is 1000 grams. Then R, which is a gas constant, 0.082 liter atom per mole per Kelvin. And pi, which is osmotic pressure, is 300. Pi you have to find out here, okay, and M2 is 342 grams per mole. Sucrose formula is C12H22O11. So from this formula you can find the mass as this. Okay, sometimes they give the mass directly, but if they have not given, then you can find. So 68.4 into 0.082 into 300 divide by M2 is 342 into volume is 1 liter. Okay, so here we can proceed with the calculation, and after calculating we get the answer. Osmotic pressure of this is 4.92 atmosphere. So this is our answer, 4.92 atmosphere, after cancelling each term. Okay, now next is the reactions. In the following reactions, write the name and structure of the major products E and G formed. So this is chlorobenzene. Chlorobenzene when treated with NaOH at 623 Kelvin temperature and 300 atmospheric pressure in presence of an acid, then we get what compound? Now this is called as a Dawes process, in which we prepare chlorobenzene to phenol. So benzene, in place of chlorine you will get OH. So this is the answer, and the name of this product is phenol. Then next is chlorine, chlorobenzene treated with nitric acid and concentrated H2SO4, that is sulfuric acid. Now this reagents we use in nitration process. So here what will happen, nitro group will get attached, but they have asked only to write the major product. So here major product will be the para product. So you can write Cl will remain here and nitro group. Para product means this group. Okay. So here name is 1-chloro-4-nitrobenzene. 1-chloro-4-nitrobenzene is the name of major product. Next question, what type of configuration is shown by biomolecule nucleophilic substitution reaction? Now this reaction is also called as SN2 reaction, and here the configuration which is showed is inversion. Okay, so there are the configuration which is shown by SN1, they show racemization, and SN2 show inversion. Then derivation they have asked for zero order reaction, so that is directly given in your textbook. You can write the full derivation given in the textbook. Okay, next is problem on first order reaction. The 3/4 of a first order reaction is completed in 30 minutes and calculate the half-life period of the reaction. 3/4 means 75% of the reaction is completed, and how much time is taken? Only 30 minutes. So we have to first, they have asked half-life, no? So for half-life we have one formula, but before that we need to know the K value for that. Okay, so K value how you will get? By using the first order reaction formula. So what is the formula? The formula for first order reaction, for zero order reaction, okay, first order reaction, it is 2.303 by T log of A by A minus X. Now you can write this as 100 as well, no problem. So A means initial concentration. So here in 75% completed means initial should be 100. So here we have time T is equal to 30 minutes. Then log of A is 100. A minus X means 100 minus how much completed. So 75. So we will get 2.303 by 30 log of 100 by 25, which is 4. So we will get 2.303 by 30 log of 4. So you have to find this answer first. So this answer comes up to 0.0767 into log of 4 is 0.6021. So this we will get 0.461 minute inverse. Now this is our K value, okay, and this we are using in the half-life formula to find the half-life of the reaction. So we will write T half is equal to 0.693 by K. This is the half-life of the reaction for first order. So K value we got is 0.461. So 0.693 by 0.461, and this will give us 1.50 minutes. So this is our answer for half-life. So T half is 1.50 minutes. Then next reaction, optional question, that is write the differential rate equation for the following reaction. Okay, differential rate equation, the very first concept which is there in your chemical kinetics chapter. So if this is a reaction, then reactants are these two, product is this one. So how to write differential rate equation? So I will show it here. this is getting consumed, so we can write minus delta H2 by delta T, which is equal to minus delta I2 minus delta I2 concentration of I2 by delta T, which is also equal to plus, now why this is plus, because it is product, so it is getting formed, so plus. Okay, so here there is a coefficient, or there is a coefficient 2, right? So whatever coefficient you have, you have to write the reciprocal of that coefficient. So here we have 2, so 1 by 2, 1 by 2, so plus 1 by 2 delta HI concentration divided by delta T. So this is our differential rate equation for the given reaction. Next question is, what is the effect of adding a catalyst on activation energy? Okay, so what the catalyst do? So catalyst lowers the activation energy by providing the alternate path for the reaction. This is the role of catalyst. So catalyst lowers the activation energy and it provides the alternate path for the reaction. The next question is, calculate activation energy with the rate of the reaction doubles for an increase of temperature from 298 Kelvin to 308 Kelvin. Meaning, when you go from this temperature to this temperature, the rate of reaction double. So if I consider K1 and K2, okay, so K1 will be equal to K, meaning when you go from K1 to K2, rate of the reaction double. So K2 will be equal to 2 K1. Okay, so this is a hint for this problem. So we will write the formula now. We have log K2 upon K1, which is equal to EA by 2.303 R log T2 minus T1 upon T1 into T2. So we know that K2 is 2K1. So I will write 2K1 upon K1, which is equal to EA. EA is the activation energy. So EA upon 2.303. R value given is 8.314. Then T1, T2. So here temperature we have to see. So T1 is 298 and T2 is 308. So 308 minus 298 upon 308 into 298. So this will get cancelled and we will get log of 2, which is equal to EA by 2.303 into 8.314. 308 minus 298 is 10, and this you have to calculate what answer you get. See, so I will take EA on one side and I will take the other terms on one side. So we will get EA is equal to log of 2 into 2.303 into 8.314 into 298 into 308 and divide by 10. So this answer comes up to 52.89 kilojoules per mole. So this is our activation energy. Next question is from P block elements. With respect to group 16 elements, write the general trend in ionization enthalpy. Now, how ionization enthalpy varies in group 16? So, down the group ionization enthalpy decreases. Okay, so as more and more shells are being added, the energy required to remove the outermost electron is less. So, that's why the ionization enthalpy decreases down the group. Next question is, draw the structure of allotrope of sulfur having S8 molecule. So sulfur allotrope S8, it comes under rhombic sulfur, and we have sulfur atoms, the 8 sulfur atoms. So one trick you have to remember while studying this, that when you have 8, the shape or the structure is this way, W. Okay, or in the textbook it is given as crown form. So here you have to assign each sulfur atom as So we have total 8 sulfur atoms this way. You have to draw the diagram neatly, okay, in your paper. Then a gas X is produced as a byproduct during roasting of iron pyrites, and gas is also used in manufacture of sulfuric acid. Identify the gas. So the gas which is used here is sulfur dioxide, which is SO2. Okay, so which is used here in the contact process. Then write a chemical reaction to show action of concentrated sulfuric acid on sucrose. Sucrose is, we know, C12H22O11, and on that if you use concentrated H2SO4, then we get activated carbon, meaning carbon, the catalytic carbon we get, okay. So 12C and 11H2O is the product over here. Then with respect to group 17, write the general trend in electron gain enthalpy with reason. So group 17 are basically halogens. So here electron gain enthalpy of the elements, it becomes less negative down the group. Okay, so that is the trend in group 17 elements. Then draw the structure of chlorous acid. Chlorous acid, we have to first write the formula HOCl. So this, we have to draw the structure of this HOClO. So it is this way. HOCl and then double bond O. So this is simple structure of chlorous acid. Then chlorine water on standing loses its yellow color due to formation of HCl and an acid. And acid Y gives nascent oxygen, which is responsible for oxidizing and bleaching action of chloride. So which acid is used here, that they have asked. So why they have asked here. So why is this acid HOCl, hypochlorous acid. Write a balanced equation for the preparation of ClF3. ClF3 is prepared by taking Cl2 plus 3F2. This is in excess to give 2ClF3. 573 Kelvin temperature is used. Now next is related to organic chemistry. Here we are given reaction and in which one part is missing, so that you have to fill. So compound P, when treated with dilute NaOH, gives this compound. So they have asked only the structures, meaning you have to write only the structure, no need to write the name. So here when we want to prepare this compound, now this comes under aldol condensation. So here we have to take aldehyde. So for this we have to take 2 propanol, CH3, CH2, CHO, as there are 1, 2, 3, 4, 5, 6 carbons, and we have to take aldehyde. So for 6 carbon we need 3 carbons aldehyde. So that's why we are taking 2 propanol. Next reaction is this ketone when treated with zinc, amalgam and HCl. So this is one of the reduction method, okay, Clemenson's reduction, in which we will get aldehyde, we will get this haloalkane. So what happens, this O is getting replaced by hydrogen, so we get CH3, CH2, CH3 as a product. Then next is this benzaldehyde when treated with this, which compound we get. So here we are doing nitration, HNO3 H2SO4 means nitration. So in this reaction, the nitro group, which is incoming group here, it will get attached to the meta position. So we get this CHO will remain and NO2 will come at meta position. So this is the product. Next is compound S treated with soda lime. Okay, so what we get here, we get ethane. So which compound we have to take? Now this is Na2CO3. 1 carbon is being used here. So how many carbon compound will be in this place, that is in the reactant place, it will be 3 carbons. So 3 carbons, CH3, CH2, then CH3, CH2. Then here, since there is CO3 involved, we will have sodium salt. So COO, sodium salt of propanoid. So sodium propanoid we have to use under soda lime to give this product. And next question is same type. Here you have to predict the structure and name the compound. So this is benzaldehyde. When treated with concentrated sodium hydroxide, we get benzyl alcohol. Benzyl alcohol means benzene with CH2OH plus sodium benzoate, that is COONe. So benzyl alcohol and sodium benzoate. Then this reaction is Rosenman reduction, second one. So here we take alkanoyl chloride. So CH3COCl, when you take, that is ethanoyl chloride, treated with palladium and barium sulfate, we get ethanoyl chloride. We get aldehyde as ethanol. Then this is benzene. When treated with CH3COCl and anhydrous AlCl3. Now this condition is in Friedel-Crafts acylation. So Friedel-Crafts acylation, we will get COCH3 group attached to the benzene. So directly it will get attached to the benzene. So this is Friedel-Crafts acylation. And last reaction here is amide. When treated with H3O and it is heated to give compound N. So this reaction is to get the product as benzoic acid and side product is NH3. So when we treat this with hydronium ion, we get benzoic acid, that is benzene ring with COOH and NH3 as a side product. Okay. So with this we finish the paper of 12th standard chemistry, Goa board 2024-25. Okay, so yeah, so with this I finished